All right, happy Monday. I hope you made through your first week of distance learning okay. I hope that you're figuring out sort of the routine for this class pretty well. I don't think it's um, it shouldn't be too confusing. Every morning you'll get a video like this. Well, maybe not every morning, but most mornings. And then there'll be some website you have to log into and do, 20 minutes of practice or whatever. And that's pretty much how we're going to keep going. To review what we did last week, we got through lessons 1 and 2 in the book, and then we did the first sprint in lesson 3, and that's approximately the pace that I hope that we keep for the rest of this time. Is about 2 lessons in the book every week, along with the other things, the IXL and the Desmos and Freckle, ST Math, whatnot. A lot of people are still asking me, how do I print this book out? Or I don't know how to download this book, or things like that. You don't have to print the book out. I wouldn't want you to. That would be a waste of paper and ink, in my opinion. You also don't need to take pictures of anything you're working on while you watch the videos and submit them to me. I will be grading your participation based on the fact that you're doing the IXL and the ST Math and the Freckle and those things that I assign, not on what you're doing while watching these videos. You should just at least try to have the book open in a separate browser window. If you can just click on it from wherever I've posted it on Google Classroom, just because it's easier to see sometimes in case you can't quite read a question, or maybe I'll ask you to do a specific problem from a specific page or something. You can look it up there. So hopefully you have that. You have this book open in another browser window. You got a calculator because we're using that a lot in this module. You've got something to write with. I've got all my markers, and you should have a piece of scratch paper that you can do some work on, while following along in the book. You don't necessarily have to have pages of the book printed out. All right, and so in lessons 1 and 2, first we started just practicing converting fractions to decimals and percents and back and forth, and hopefully you're getting kind of good at that now, but it's okay if you're not. We still have plenty of time to get good at that. And then we learned that the word percent literally means out of 100, or for every 100, or divided by 100. It's just a way of talking about ratios in terms of 100, because our brains like that number. And then we started talking about what kind of problems do we answer with percents. And the first type of problems are these problems that have these 3 pieces. And we refer to them as the part, and then the whole, and the percent. And these 3 things are related by this equation. The part equals the percent times the whole. But then using our algebra skills, we can make 2 other equations from that. If we divide both sides of this equation by percent, then we get that the part divided by the percent equals the whole. And if we go back to the first equation and we divide both sides by a whole, then we get the part divided by the whole equals the percent. And so that's one way to handle these questions, is to just identify which 2 out of the 3 pieces the question is giving you, and then use the correct calculation or equation based on which pieces of information you have and which ones you're trying to find. Another way is if you just rewrite any of the questions in a really simple question, like what number is 27% of 80, then you can just translate that into an equation where you see what number, you put a variable, and then where you see the word is, that's an equal sign, and then where you see the percent, just convert that to a decimal or a fraction. Where you see the word of, that means to multiply, and then number 80, number 80. So a couple different strategies on how to answer these questions. I want to add a little bit of extra terminology to what we're doing. Sometimes it's better to refer to what we've been referring to as the part as the quantity. Sometimes it just makes more sense to say quantity than part. The main time that it makes more sense to say quantity over part is when the part winds up being bigger than the whole, which, remember, I told you that can happen sometimes. And then it feels weird to call something a part when it's bigger than the thing it came from. And so sometimes we might use the word quantity instead, but it literally is referring to the same thing. And also, sometimes instead of saying part, we'll say new. Because sometimes we'll do these questions where you start with a certain amount, and then it says increase it by 20% or decrease it by 20%, and you get a new amount. And it makes more sense to call it new instead of part. And because of that, sometimes we'll refer to the whole number as the original number. When we start doing these questions where like it says, oh, you had, 417 of these things, but then you lost 27%. How many do you have now? Well, we'll think of that number, 427 or whatever it was I said. We'll think of that as the original number. You could also think of it as the whole, but I just want you to be flexible in knowing different ways we're going to use the words. All right, I want to start this lesson off by asking you to do the other sprint. So you did this sprint last week, the lesson 3 sprint, sprint A. Attached to today's announcement, there should be the sprint B. So go ahead and get that done. And then you can go and pause the video now, and then you can check your answers against mine in a second. So I'm assuming you're pausing right now. Okay, you should be coming back from a pause. And so here's the answers to the sprint B. I think I got them all right. I don't know. See if you can find a mistake in there. I'm human too. Go ahead and pause the video now so you can look at all the answers or whatever, but I'm going to keep moving on. All right, so let's get into lesson 3. The first question says, if each 10 by 10 unit square represents one whole, so this is a 10 by 10 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And I'm going to assume that that's 10 there. So they're saying that this whole 10 by 10 thing here represents one whole thing. Then what percent is represented by the shaded region? So we've got one whole here, and we've got an extra, well, it looks like 10, 20, and 5 boxes. So I'm just going to write myself a note here that this was 25. And that's 25 out of another 100, right? So the first box represents 100%, and the second box represents 25%. And so altogether, I believe that they represent 125% of one of these boxes. Okay, and now it says in the model above, 25% represents a quantity of 10 students. Okay, how many students does the shaded region represent? So every 25 boxes, so like here's 25 that I'm going to shade in this kind of dark green color. I'm not going to fully shade them in or do like a perfect job, but okay, so there's the first 25. And then we do another 25 in purple. Okay, so each 25 box or 25% area that I shade in represents 10 students, or in other words, 25% of the students is 10. And so I'm pretty sure we're going to wind up with 4 of these shaded regions, which means we have 4 times 10 is 40 students. But that's just in this one box that I shaded in, right? This is 4 times 25% to make that 100%. And each 25% represents 10 students, so 4 times 10 equals 40. But that's just that box. We gotta account for this other 25 here, which is obviously just gonna be another 10 students. And so I'm just gonna say that's 10 more students. So 40 plus 10 equals 50. So this is a case where like the part kind of turned out bigger than the whole, because in this case we have 125% is our percent, and so the whole is represented by this box here. So the whole is this 40 students, like maybe like one really big class of 40 students. But for some reason we have 125% of that whole, and so the 50 is actually a part of the 40. And that's really weird and confusing. I totally am okay with the fact if you're confused by what I just said, it'll get clearer as we do more of these questions. All right, so it says, the members of a club are making friendship bracelets to sell to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce over the weekend? Okay, so they gave us a part, right? Or the quantity, if we wanted to call it that. In this question, they made 54 bracelets out of how many they want to make. And then the whole in this case is the 300 that they want to make, right? And then our job in this case is to find the percent. And so we could go back to those three equations that we made using algebra and words, and we try to find the one that would help us find percent if we don't know what it is. Because remember, that's our unknown piece of information in this question is the percent. Well, equation number 3 says if you know the part and the whole, just divide them and you get the percent. So let's just do that. Let's put the part over the whole, and we will divide them using a calculator. We got 54 divided by 300 equals 0.18. But that doesn't mean 0.18%. Right? Whenever we do this, we always get our answer in a decimal or a fraction, and then we have to convert that to a percent by dividing by 100, right? That's what percent means, divided by 100. Wait, sorry, I misspoke there. Percent means divided by 100. And so in order for this to be equivalent to that, we need to multiply this number by 100, which would mean we move the decimal point over 2 spots, and we get 18%. All right. Another way you could have done that question, just to keep this in mind for you, is that the question is essentially asking 54 is what percent of 300? And then just turn this into an equation. 54 means equals what percent, that's where we always use a variable, and then of 300, so times 300. And then if I wanted to solve this equation for x, I would just divide both sides by 300, and I get 54 over 300 equals x, just like we just did. We get 0.18, we convert that to 18%. It's the same thing, it's just a different way of doing the question. All right, let's move on. Let's see, we're at 12 minutes. Maybe we'll do like one more. We'll see how long it takes. All right, so it says Anna produced 32 bracelets of the 54 bracelets produced by Emily and Anna over the weekend. Write the number of bracelets that Emily produced as a percent of those that Anna produced. Okay, so they made 54 total. And Anna made 32. So I've got to figure out how many Emily made, right? That's her name? Yeah. Okay, well, that means that Emily made however many are left over, right? So Emily equals 54 minus 32. I believe that is 22, right? Yeah. Okay, so Emily made 22, Anna made 32. And what does the question want? They want me to write the number of bracelets that Emily produced, so that's 22, as a percent of those that Anna produced. So that means that the number that Anna produced is going to be the whole in this case. Something that clued me off to that is the fact that the number that Anna produced comes after the word of, and that's usually a clue to treat that number as the whole. So in this case, the part is going to be the 22 that Anna made, and the whole is going to be the 32 that Anna made. Now, keep in mind, they could ask you to do this the other way. Oh, yeah, that's literally what they're going to do in C. So I don't even need to say this. I'm going to show you the other thing that we could do in part C. So let's see here. Percent equals part divided by whole. I'm just using that same equation again. So in this case, it's going to be 22 out of 32. We grab the calculator and we get 22 divided by 32 equals 0.6875. But remember, it's not 0.6875%, right? That's our percent as a decimal. We need to multiply it by 100, or in other words, move the decimal point over 2 spots. And we get 68.75%. So that's a little under 70%. So let's see here, Emily only made like 70% as much bracelets as Emily made. So Now what happens is in question C, they're going to ask us to do the question the other way. Let's write how many that Anna made as a percent of how many Emily produced. So in this case, the whole is the 22 that Anna produced. Sorry, that Emily produced. I had to rethink that for a second. The whole is the 22 produced by Emily. And the part is the 32 that Anna produced. Right? So this is like we're making the same exact comparison that we made in part B, but we're making it the other way. In part B, we came to the conclusion that, oh, Emily only makes a little less than 70% of what Anna makes. And so now we want to be able to say the sentence the other way. We want to be able to say Anna makes blank percent of what Emily makes. And I know that this percent has to come out over 100%. I know that because, first of all, Anna makes more than Emily. So it's got to be over 100%. I also know that anytime you make a comparison between two numbers, in one direction, the comparison will be under 100%, and in the other direction, the comparison has to be over 100%. And if you just think about that statement for a second, like let your brain wrap around it, I think you'll see why it has to make sense. The one exception would be is if the two numbers are the same. Like if both girls made the same number of bracelets, then I guess that statement's not true. All right, so let's do percent equals part divided by whole in this case. And this time it's going to be the 32 divided by the 22. So we're just flipping the division or flipping the fraction in this case. And so let's see here. We are going to be able to say that Anna makes what? Probably 130 some odd percent compared, maybe 150. 32 divided by 22 equals 1.454545 repeating. I'm just gonna go one time with the 45. I don't feel the need to write all those 4 5s right now. Let me make sure you can see it. And then that equals 145%. And so this is one of those cases where the part is bigger than the whole, which is kind of weird. And so this is one case where you could argue instead of using the word part, maybe we should call it the quantity. Because it makes more sense to compare a quantity to something that's bigger than a part to something that it's bigger than that. I don't know, just the language is weird. So you want to call it the part, that's fine. You want to call it the quantity, that's fine. It's all good either way. All right, I think we'll stop there for today and then finish lesson 3 tomorrow.